Good morning, everyone. Today we are going to do the chapter number quadrilateral, in which there is a theorem that line joining to the midpoints of the sides of the triangle is parallel to the third side and half of the third side. There is a theorem and the mostly chapter based on this theorem only. It is given that a triangle ABC, and if two midpoints of these lines AB and AC, that is G and F, if we'll match these two midpoints, then prove that this line will be parallel to BC and half of BC also. So what we need to prove is that GF is parallel to BC and GF is half of BC. This is what we need to prove. Fine. So let's start. First of all, in this triangle ABC, G and F are midpoint. In construction, we will produce this GF line in such a way that GF is equals to FL. So what we will do, produce the line GF in such a way that GF is equals to FL. Okay, then we will match L with C. Clear? Now we are having two triangle AGF and CLF. Now in triangle AGF and CLF. In these two triangles we can say, as G was the midpoint, and obviously so we can say BG is equals to AG. Some properties I am telling you. So C and CF is equals to AF, right? Because F was the midpoint. So in these two triangles I can say AF is equals to CF. Why? Because F was the midpoint. Okay. Second thing is these two angles, vertically opposite angle. So angle AFG is equals to angle CFL, vertically opposite angle. Third, we know GF is equals to FL by our construction. Okay, so here we will write GF is equals to FL construction. So by side angle side congruency rule, by side angle side, the triangle AGF is congruent to triangle CLF. If these two triangles are congruent, then by CPCT we can say this AG is equals to CL. So AG is equals to CL, right? And we can say angle A is equals to angle C also by CPCT. So angle A is equals to angle C. We can see that A and C are alternate angle also, and when alternate angles are equal, lines are parallel. So we can say here, when alternate interior angles are equal, then lines are parallel. Which two lines are parallel? BA is parallel to CL. As we know that this AG is equals to CL, and as this G was midpoint, so AG is equals to BG also. So by these two we can say that BG is equals to CL. Here we said BA is parallel to CL. This BA is parallel. So we can say BG is also parallel because G is the part of BA. So here we can say BG is parallel to CL. Sorry. So by these two, BG equals to CL and BG is parallel to CL. By this we can say this quadrilateral GBCL is a parallelogram. So we can say is a parallelogram. If it is a parallelogram, so we can say that GL is parallel to BC and GL is equals to BC also, these two. Right? Now GL is parallel to BC, so can we say GF is also parallel to BC because F is a part of GL. So GF is also parallel to BC. The first thing which we have proved. Now second, GL is equals to BC. We have two part of GL, that is GF and FL. So at the place of GL, I am keeping here GF plus FL is equals to BC. When these two were equal, so I can replace FL with GF. GF was equals to FL, so I have replaced FL with GF. GF plus GF is equals to BC. 2GF, so GF is half of BC. So this was our whole question which we have done.